Leetcode problem 51, the n queens problem. In this problem, we get as an input an integer n, and we need to place n queens on an n by n board. We need to then produce a string. The string length would be n by n, so n squared, and at every point, at every cell where we are going to place a queen, we need to place the letter Q. And at every place where we do not place a queen, we place the dot. So just a brief reminder, a queen can move in any direction. A queen can move horizontally, right, on the lines. A queen can move up or down, and a queen can move in all diagonals. Let's look at understanding the problem and its solution with the trick. So first, let's understand the problem, and we need to notice that each and every queen has to be on a different row. There could not be multiple queens on the same row because then horizontally they will collide. Notice that each and every queen has to be in a different column. We cannot have multiple queens on the same columns, otherwise they would collide. Notice that each and every queen has to be in a different positive diagonal. Let's take, we have two diagonals, this one and this one. Let's consider this one the positive. So each and every queen has to be in a different positive diagonal. We cannot have multiple queens on the same positive diagonals because otherwise they would collide. Notice that each and every queen has to be in a different negative diagonal. We cannot have multiple queens on the same negative diagonal, otherwise they would collide. This brings us to the state. Which state do we need to store? Every time we place a queen, we want to store the column that the queen was placed on, so that when we continue placing queen, we would not place another queen on this column. We want to store the positive diagonal that this queen was placed on, so that we would not place another queen on this positive diagonal. And we want to store the negative diagonal, so that next time we place a queen, we do not place a queen on this negative diagonal. Do we need to store the row in the set? No, because we are going to scan by row. So when we get to row 2, we already placed the queen on row 1. We would not consider row 1 twice in this case. And now to the trick. How it's easy to store a state of columns. A column is from 0 to n-1, and whenever we place a queen, we just say that this column, let's say column 2, we put it in a set. Column 3, put it in a set. We placed, and then when we place a queen, we just check if this column number is already in the set. What about the positive diagonal and negative diagonal? So the positive diagonal is if we place a queen at specific row and a specific column, which is always the case, then all the row minus column, which is the constant of where we place the queen, we cannot place the queens. If we place the queen on cell 2, 3, then we cannot place any queen on 2 plus 3 is 5. We cannot place any queen on cells whose the sum is 5. Okay, because this would be row plus column, this would be row minus column. Then we're going to look. We're going to take the first queen, put it in the first row, check if we can put it, then go to the second row, then go to the third. Now let's look over the solution. Solve n queens. We said that we need a state. We cannot put queen in these columns, in the columns that we put in this set. We cannot put queens on this diagonal, positive diagonal and negative diagonal. We cannot put any queen on this diagonal too. This is going to be the result. This is going to be the board in Python. we're going to have a two-dimensional array. So we see here square brackets, one-dimensional, and then another dimensional. We time it by n because we are going to place dots, which means no queen. Initialize the board with dots all over the place. Then we are going to start. So we are starting with row number 0 with backtracking. Backtracking just means try to put a queen. If can, put it, continue. If cannot, continue. Okay, so backtracking, we start with backtracking of 0, which means we are at row number 0. Do we already, the basic framework of all this backtracking is going to be first to check if we have a solution. If we have a solution, add the solution, and that's it. Just add the solution and continue. And although we didn't specify an explicit exit, it's going to continue here for row number n, which is outside the bound, and then exit, because it wouldn't be able, we have a solution. We cannot add any additional queen. It would just continue, check, see that it cannot add anything here, and exit. Okay, so this is a kind of tricky, because you see, we are on the backtrack, and we have seen that we are out of bound. Okay, basically R is n. We have a solution. We don't do here exit or return or anything. Okay, we just continue, and it would exit this function and continue to here. Okay, so if we have a solution, just add the solution. That's it. Tricky, because we don't do continue or exit, but that's life. Okay, so now let's say we don't have a solution, means we need to continue to try and place queens. So we are on the next row because we came to this function either from the first 0 row or from the next row. Try to put a queen. If the queen cannot be put because it's already in the calls or one diagonal or the other diagonal, then continue to the next column and try on the next column. If it's possible to put a queen, let's mark this column and the diagonals that they are captured by the queen and mark the board with the queen. Next, once we have placed the queen, we want to continue to the next row and try again to put the queen on the next row. If we either finished placing the queen on the next row successfully or unsuccessfully. Unsuccessfully means we tried to put a queen, but we could not, so we exited this function, or we successfully placed the queen. Then this means that we have that the function of the backtrack has finished. Okay, we enter the backtrack, enter until we finish. And when we finish, this means that we have finished successfully creating a board with all the queens, or we failed. So now we need the next solution. If we finish successfully to create a board and we finished with all this backtracking, then we want to try other combinations. So we want to remove the latest queen and try to put it on another column because we might have additional solutions. If we finished backtracking and it wasn't successful, then we want to remove the queen and try on a different column. So basically the structure is this. The structure is this. Start from row number 0. If we have a solution, just add it to the result and continue. If we don't have yet a solution, we didn't reach the last row, then go over each column and try to put a queen, successfully put a queen, mark it in the state, continue to the next row. Finished with actually here, we finished with all rows. Okay, we finished with rows because we call recursively backtrack. So we finished with all rows. Once we finish with the rows, we want to backtrack and try to put the queen on another place. So we remove the queen from the last place that we have placed it, and that's it for the solution.